Exercise P2-11, we're dealing with a 12-sided shape with 8 holes and a square cutout in the middle. The 12-sided shape is called a dodecagon, which isn't really relevant to what we're doing, but just for future reference so you know what it's called. In this example, I'm going to be using some patterning tools to get exactly what I need. So the first thing that I'm going to do in Inventor is I'm going to go to New, and this is a metric drawing, so I'm going to click on Metric, Standard Millimeter IPT, and Create. Now I'm going to start my 2D sketch just like I always do. I'll do this one on the front plane. For these ones where we only have a two-dimensional view, it's not really important whether you go top or front. So at this point, I'm going to create a polygon. So under the rectangle flyout, I go all the way down to polygon. Left click it, and I want 12 sides, and then my center point is going to be the center of the drawing. And I know that my top and bottom are straight, so I want to draw them slightly crooked, just so that I can make sure I know that they're not straight. After creating the polygon, I need to select Done from the menu. Now I can apply a horizontal constraint to this top line, and that's going to lock that horizontally. I can then place a dimension from flat to flat of 180 to set my dimensions up so that they're accurate. At this point, I can either go back in and put in the square in the middle, or I can save that for another feature. It doesn't really matter, so I'm going to go ahead and put it in now using, again, the polygon command. In this case, I've got a polygon with 4 sides, so I'll click the center, and again, I'm going to make it crooked just so that I know that it's crooked. And I know that I need to put a horizontal constraint on it. If you draw it very, very close, you may forget that you need a horizontal constraint and then not be able to constrain it later on. So now we've got our dodecagon shape and our square shape. At this point, I can finish my sketch. And now I'm going to extrude the thickness, which is, in this case, is 6. So I'll select my profile, 6, and hit enter. Now I need to locate my holes, and I'm just going to locate one hole for right now. So I'll left click on the face, and I'll click on my sketch tool. I'm going to draw a circle representing the bolt hole circle of my object, and put a dimension on this of 120. Then I am going to locate just a point at the very top of that, and I want to put a vertical constraint between this point and this center. Now that's locked into place with no dimensions. Just because I've got my bolt hole circle in, it works out great. So now I can finish this sketch. I'm going to click on the hole command, and because I have a sketch in there that has a point in it, it automatically says placement from sketch and selects all the points that I picked. So because I only picked that one point, it's automatically got all the clicks in that I need to set this up. I know that my termination is through all, and I need to set the diameter of the hole up to 20. At this point I can say OK, and it creates my first hole. Now I want to do a circular pattern. Left click on the hole as the feature. For the rotation axis, I'm going to come over here to the origin, and I'm going to select the axis that represents the center point for this part. I can see that the y-axis is vertical, the x-axis is horizontal, but the z-axis represents the center, so that's the one that I'm going to pick for the rotation axis. So I'll click on Z, and this says that I have 8 holes, so I'll type in 8 right here and hit OK. And in looking at this, I can now see that I've got all 8 of my holes, I've got the completed shape, and this is the completed P2-11.